So today we're having this October session of Guest of Honor TechTalk series. This monthly event that we bring special guests having a successful transition from academia to industry or launched their own tech startups to the world. So they share their personal stories, lessons learned, real world strategies for navigating a career shift. And with that, this month we have a very special guest from South Korea, Dr. Ulanbek Auyeskhan. He's a staff engineer at Samsung Electronics headquarters, particularly mobile experience business, advanced coloring materials, and finishing lab in Suwon, South Korea. Dr. Auyeskhan works on metal 3D printing materials for Samsung smartphone components. He earned his PhD in mechanical engineering from UNIST University and later served as assistant professor at Astana IT University. His research has been published and presented in leading international journals and conferences. Dr. Auyeskhan is passionate about integrating material science and 3D printing and AI to shape future of product design. So with that, I want to Ulanbek, again, thanks for joining us today and sharing your experience. Really appreciate it. I think this session will be very helpful. And before starting, please, guys, can you share where you're joining from? Yeah, today we have Auyeskhan from Finland. He's a professor working there. Who else? So, you guys, you can just type in a chat where you're joining from, so know you. And yeah, Ulanbek, you can share your screen. And yeah, we have guys from South Korea, Hamzat.
Yeah. So good evening, everyone. Maybe good day to people who are in Kazakhstan or any part of the world. So let me share my screens. I'm trying to do that. Just a moment.
Yeah, before we start, if you have any question, you can write in the chat in whatever language is convenient for you, English, Kazakh, Russian. And yeah, it's a non-formal meeting, and we appreciate the Professor Dr. Auyeskhan's time, so he can answer your
Okay.
question. And I think we need to use this opportunity. Thanks.
Yeah. So can you see like in a proper way, or is it like widened or something like that? How do you see my
Uh,
screen?
yeah, it's wider.
Oh, okay. So can you? Oh,
Yeah,
I
now it's
think
better.
this only the. And now it's
No, no,
better,
no,
right?
now
Yeah.
it's better.
Okay.
Yeah.
I think that there was some problem. Okay. So this is just a brief information about me. I was born and raised in Florida City, and this is the list of the education that I obtained. So I am originally from. I mean, I studied in UNIST, which is located in in the city of Ulsan, which is called as a kind of the industrial capital of South Korea. Um, I came to Korea like around 2011, and since then, I have been staying here for like 12 or 13 years. Except gap years and etc. I'm going to go through. Now and then I got my master's in QIST in nuclear and quantum engineering and the PhD in mechanical engineering. So as you can see, it's kind of diverse set of the education and some skills. So I had kind of the change of minds during my, how can I say, the pursuit of knowledge, especially after my master's. So I totally changed my mind and then decided to pursue something else. So in that year, after I graduated from my master's, and then I decided to pursue something else. Okay, then the research experience, contains like I actually worked in the 3D printing manufacturing center, which is located at the same city. So the good thing, is people might ask, like, might be curious, why I came to UNIST again after I finished my bachelor. So why not the other countries? So that's quite understandable because I had a very good opportunity to combine my PhD academia and then the industry. So kind of offer was the offer was I had to like stay in the university just for my studies and then work in an like industrial institute for the other industrial projects. So it was a kind of unique opportunity, which is not that common in Korea. And then of course pay was good. And then uh in as an academic experience, I had an experience of working in Nazarbayev University as a research assistant and teaching assistant. Then I think Nazarbayev University also quite helped me to like shape my um education and some kind of academic experience, especially after my master's. And then I went for my PhD after working in Nazarbayev University. And then after obtaining my PhD, and then went for Astana IT University as a assistant professor. Now currently uh, as working as a staff engineer at Samsung Electronics, and the lab is called the CMF lab. This is a kind of the like 30,000 people are located in the campus. At the same time, I am an academic advisor as in in Kazakhstan project, as Dr. Gamjan mentioned. We kind of working, trying to establish a university powered and designed by original guys at located in Daejeon in South Korea, and then try to like establish it in the city of Almaty, hopefully. And so, as the topic says, the not the rocket science, a pocket science. So, why I was interested in 3D printing in the first place is that the traditional manufacturing of rockets, especially as you can see here, like it involves 100K parts, and then the build time is like 2 years, more than 2 years, and iteration time means like trying to uh fix the parts that are broken and then try to iterate because of some design mismatch or something like that. And then, of course, the complex supply chain because all of the different parts are coming from the different vendors, different companies, and it has very, very high complexity. This is a picture of me when when I was in high school, 2010, and then Johnson Space Center in Houston. And in case of the metal 3D printing, especially and additive manufacturing, as you can see here, like it's 99%, probably, yeah, if I'm not mistaken. Yeah, thousand on less than 1,000 parts, because as you can see in the picture, there are like two robotic arms trying to print the chamber, like in a rotating manner. And build time usually is quite short comparing to the like in the traditional case, and iteration time is less than a half year. And it's very simple supply chain because of the most of the parts are only printed within one kind of the hangar, well, let's say, it is very, very simple supply chain. You don't have to bring some complex parts from different vendors. You just need some kind of the supply chain of the materials that are printed into the robotic arms. And of course, very, very sophisticated the software-driven factory. It has to have a very well-designed AI aided for example, if there is a kind of error during printing, it has to have the capability to fix that during the printing so that imagine that like when you are printing in the middle, there's some kind of error, and then you might say, wow. So the like AI tries to fix that automatically so that you don't have any defects during printing. So there will be kind of some kind of a camera, a sensor camera that fix that. So this is actually one of my favorite startup companies called Relativity Space. It has a Stargate 3D printer building rocket parts. I think it is very very like competitive, especially in delivering the parts, the rocket parts to the like to NASA or the SpaceX companies. And another motivation for using the 3D printing is that the fuel nozzle, as you can see here on the left side, top left side, the uh, especially this one, 25% of weight reduction, and then from 20 parts to one single part, as I'm going to show you later. So there will be like a this fuel nozzle contains like 20 different parts, which can be only printed, 3D printed, within one single part. It's very, very uh, robust technique. And on the right side, that's the advanced turboprop engine, and it has the from 855 parts to 12 parts. It has a part count reduction. So that's the methodology is called the part consolidation. So as I have mentioned in previously, the part consolidation, I mean, the capability of 3D printing is in that it tries to reduce the number of the parts and then they reduce this very complex supply chain. Next, so yeah, it's not going to be very technical. I'm just trying to just the kind of the mention what does this simple term means. I'm not going to go into detail. Just look at the pictures. So the originally these are the designs that I had an opportunity to make, especially on the left side. The bucket. This is the bucket that is used for the turbines, and on the right side it is the use it for it's a die, hot stamping die, which is used especially in automotive industry or aerospace. It has to have a capability to cool when there is a metal flows. So it has to have the very uh, well-designed structure. And on the left side is the trying, I think we tried to have a hydrophobic surface and try to make the very thin part and then challenge the capability of the 3D printer that we had in the institute. Okay. So next is, yeah. So these are the capabilities of the 3D printer that can make nowadays, but not limited to what it has in the screen. So this is the lot, not this call on the left side. This is in my hand. That's the lattice structure can be used for human bones, especially hip implant. And there were successful surgeries especially in the head skull, I think in the Busan University Hospital, if I'm not mistaken. And it has also capability of printing in a multi-material way and part consolidation and team feature parts. This is the thing that I made when I was doing my PhD on the right side. That is used as the bipolar fuel plate, which is used for hydrogen drone. Okay. So fuel cell drone. That's the plate which allows the hydrogen and oxygen allows the hydrogen and oxygen gas to flow. And yes, these are the below things are not that important, just for depicting the capabilities of the 3D printing. And what else? Yeah. So this is one of my projects when I was doing my PhD. Uh, the part is actually called the hook assembly, which is used for the lifeboat boats, and it was an order from the lifeboat company. So it was very sophisticated assembly and it had like 74 parts, and then I tried to reduce it to 28 parts, so like almost 50 parts decrease, which a kind of a proof of concept of capability of 3D printer, especially in the metal 3D printer, which is not that easy to utilize in the industry, which is like a traditional industry. And this is the part that I also designed. And the old design was something like this on the right side. Like orange one is very old and in welded and not accurate. And on the left side, the one which has been um 3D printed, especially the buckets and the so its original looked like this. I still remember that I had to sleep in the lab in order to make sure that it doesn't fail during the printing. Okay, so next is okay. So this is just some kind of introduction for the 3D printing technology. And a brief history of Samsung Electronics, especially the Samsung Electronics. It is we call in Korean Samsung Chonja. Samsung means the three star. Okay, Sam means three, Song means star, and Chonja is literally electronics. Um, it has like a main major businesses called DX and MX. I'm going to share in upcoming slides, and it has a very unique history, like from dried fish or groceries and especially noodle to smartphones. Okay, so it started actually with the kind of the Samsung Group started with the trading of noodles and groceries. And this actually on the bottom left side, the picture, this is the very, very first building of Samsung, which is still, I mean, still available for visitors to see the actual building that the Samsung has started. So it is untouched and in a very safe, condition. So in my case, I hadn't still chance to visit this, but those who say that it is still located in Daegu and a very safe place. And what else? And yeah, the remarkable things were especially in 1970s. 1970s, I think it's not mentioned in here. So in the 1970s, it had started it started with the semiconductors like drums and etc. So the other major business of Samsung Electronics, which is DS, is quite involved in this business. I mean, the semiconductor-based chip business. Now, like from as you can see here, from the start from trading the noodles and groceries to the very recently product of, I think this is the latest product of Samsung Electronics, which is Galaxy XR, which has a lot of um capabilities and it's very unique and robust multimodal AI. I still haven't had a chance to experience it, but I think it is available in a nearby building. So maybe if I have a chance, I can kind of provide a review. You can follow my Instagram. I will tell you later. And on the top right side, you can see that the Samsung phone is actually featured in a matrix, if I'm not mistaken, that is reloaded. Перезагрузка. So matrix reloaded, actually that phone which is like a moving sliding. So that is used in the matrix one. It had like a 5,000 limited version. And yeah, next slide is about, these are the main business areas of Samsung Electronics Device Experience Division. So on the left side, the leftmost side, actually visual display business, which produces the uh, TVs and etc. But when the business that I am involved with is in the mobile experience as working as in the R&D center of mobile experience business. And in there, we actually involved in the consumer electronics such as the watches, the Samsung phones, and the earphones. What else? Laptops, and the the Galaxy Visions that you have seen in the previous slide. So we in our part, our lab is trying to develop, starting from the materials and to coloring and I mean manufacturing in different ways like 3D printing and there's some forging and in like injection molding and different manufacturing methods by involving different manufacturing methods and then and until finishing. So that involves actually the coloring, the coloring that you see here, and it has a very unique design stories actually. So we receive the different design concepts from our colleagues in design teams, and then try to check the manufacturability in terms of the coloring, materials, and finishing. That is called CMF. I think that's quite a popular term in the smartphone area or even automotive industry. So that's called the CMF. That's it. And oh yeah, I think one of the unique and notable of the events of this year was the Galaxy S25 smartphone and like series of Ultra and just as S25 like Aegis. These are powered by the Qualcomm Snapdragon Elite 8 Elite, and this is our boss, the TM. We call him TM, and of MX Business Division. And as you can see here on the right side, under my picture, you can see that that's the answer to which kind of one of the platforms tries to rank the Android and iOS phones in terms of the performance and system on chip and AI. So in terms of the system on chip, we can see that the Samsung's S25 Ultras, especially, they have this Qualcomm Snapdragon 8 Y8 Elite. Why is it important? Because nowadays you can see that the AI agents or AI assistants are very, very helpful for our everyday lives in like in work especially, and so they need a very huge amount of memories and CPU and GPU. So that's why it's quite important just for provided they try to provide a kind of the big picture of what is going on in the smartphone business. And yeah, okay. So, and one of the also notable events of this year was the Galaxy Z Fold 7. And yeah, I think this Z Fold 7, I experienced myself, maybe someone has from the audience, is much thinner than my S25 Ultra. As you can see, I think I'm not sure which chocolate is that, maybe KitKat or something else. And it's comparable with the even chocolate wafer bar. And and when it's in like unfolded, is much slimmer than just two slices of cheese stacked together. Like these are two slices of cheese. So I think this manufacturing, I mean, design requirement or design constraint obtained by our design team, they try to actually give us a kind of the customer requirement in terms of the customer requirement, functional requirement, and then we try to see the current and the investigate the current our manufacturing R&D capabilities, whether we can meet these design constraints, and then try to manufacture based on the design on these design requirements. Not, of course, at the same time, maintain the robustness and the capability of in terms of the functionality, for example, in terms of the cameras. So even though we try to make it thinner and thinner, we have to also make sure the batteries are not. I mean, batteries have the same power and same amount of working time. So we should have to have the kind of balance in terms of the design and in terms of the manufacturing capabilities. What else? And yeah, so that is for Samsung. And first we described about the 3D printing technology and etc. and how we try to make sure. So I couldn't include the how we use the 3D printing in our smartphone business because it's kind of a confidential information. So I cannot disclose it. I'm sorry, but as you can see here, like some parts, I'm not involved in the internal parts of the smartphones. We try to make sure that outer part appearances are shiny and sleek designs, and it has some durability. We are doing a like crazy reliability test to make sure that our phones do not break when we drop it in like in some kind of salty environment in like in a beach or something like that. So we have a lot of simulation environments to test the durability of these phones after we manufacture, of course. But details of these things cannot be disclosed. I'm sorry. And the thing that I'm involved in the next part, as I said in the very first slide, is the KAIST project. So actually, these Samsung Electronics, like companies, big chaebols, we call them in South Korea as the big four chaebols, are actually accounted for like more than 40% of the GDP of South Korea, and like some SK company, which are also quite in, very um, popular in chip industry, like semiconductor industry. SK, Hyundai Motors, and Samsung. What was the next one? LG. Yeah. So these four companies account for more than 40% of the GDP of South Korea. So that's why these companies, which are called chaebols, like family-owned companies, are kind of quite unique in Korea, especially in Asia. And they, uh, so in 1970s, Korea, in 1960s, Korea tried to um, make like a kind of the, how can I say, the industrial development in terms of the university. So try to make sure that the university, newly opened university such as KAIST, has to ensure the development or economic development in the 20 years. So the professors from Stanford came to South Korea and then make sure like wrote a so-called feasibility studies, and then they laid out like a strategy for 20 years of development of South Korea. So they didn't focus on like math, some natural sciences. They all mostly focused in applied sciences, which are directly involved into the industry. So the main after the first graduates, or one of the first graduates of this university, KAIST, actually established very highly involved in the development of Samsung Electronics company. So we try to make sure uh, this kind of unique story of Korea, which has the very unique university such as KAIST, we try to make sure this university is also has a partnership in Kazakhstan. And these are key directions in R&D departments, which we think that Kazakhstan needs it urgently in maybe in a couple of years. So it can be expanded for other departments as well in a later stages. But we think that nowadays Kazakhstan needs these five very special R&D departments such as chemical and biomolecular engineering, department of nuclear and quantum engineering, mechanical engineering, computer science and AI, and business administration. So yeah. This is one of the directions of our president because it was a kind of direct task from the government to establish like uh, top under maybe like 100 universities, top 100 in a ranking. One of the very unique universities in Korea is a kind of MIT of South Korea, let's say. And so the these are the milestones, and the way to establish KAIST was not that easy. So especially our team members, well, I think the picture is not that clear. Danyar, Mirza, and Dana Khanum are the very early, how can I say, starters of this project. I was just involved in the middle. Mm, in the establishment of the KAIST as a kind of academic and industrial advisor of this project. So we expect that the first admission will be maybe next year. So this is just a preliminary and tentative schedule. So it might be delayed or maybe even earlier, depending on the funding and depending on the feasibility studies. By the way, currently there is ongoing study which is called the feasibility study that KAIST also had done in their early establishment years. So the uniqueness of Korean universities, especially KAIST, the professors said that we are not just going to establish it without prior knowledge and history and the R&D situation of and industry needs of Kazakhstan. So, uh, and then they said, okay, we have to do the feasibility study. So that was kind of very inspiring. Personally, it was very inspiring because in order to make sure that the opening of this university is not just directed, I mean, its target is not just make sure that people like just take classes and go for, I mean, abroad or somewhere else. We try to make sure that the Kazakhstan industry needs are met based on the feasibility study that is ongoing by, and then led by the KAIST university professors. So I just wanted to emphasize that this gonna be kind of unique case in our history. Yeah. Oh, okay. So this is just a list of the social media and KAIST KZ, and it has also Instagram KAIST KZ. And these are my personal Google Scholar, LinkedIn, and my Instagram, my personal blog. I hope it was interesting. And if you have any questions, you can ask me whatever you want. Thank you.
Ulanbek Mirza, I really appreciate your information that you provided, especially starting from your
Yep.
career that you did in Kazakhstan, later went back to Korea, and especially working in industry. We understand that there's a limitation of providing some information regarding the company policies, but overall, really appreciate it for your time. If you want, you can actually turn on the video. And yeah, so guys, now we're going to Q&A session. Please, you, as I said, feel comfortable to use
Mm-hmm.
any language. There's a unique opportunity to
Mm-hmm.
directly ask your question. And before, so we have Marlene's question, but before Marlene's question, I want to ask personal. Yeah, I will ask in Kazakh. So, Ulanbek, рахмет сізге
Mm-hmm.
неге презентацияңызға. Менің сұрағым енді сіз бағанағыдай бакалаврдан бастап PhD-ға дейін Кореяда жасадыңыз. Сосын PhD-дан кейін
Mm-hmm.
Астана IT университетіне келдіңіз, жұмыс істедіңіз.
Mm-hmm.
Жалпы
Mm-hmm.
сол кездегі сол академиядан индустрияға кетудің қандай ойлар болды, қалай бұл қазіргі жұмыс таптыңыз? Бұл бірінші сұрақ. сол кездегі. И екінші сұрақ, қазір енді жұмыс істеп жатқаннан кейін жалпы өзіңіз қалай сезініп жатсыз, қайтып академияға бару ма, немесе былай индустриядағы жұмыс несі ритмі ұнап жатыр ма, қалай ойлайсыз осы жағын? Рахмет.
Так, біріншіден, а, ол көптеген факторлар болды негізі. Докторантура бітіргеннен кейін де негізі Кореяда қалған немесе басқа ойлар болған, бірақ кейбір отбасылық жағдайларға байланысты Қазақстанға қайту керек болды.
Мгм.
Қазақстанға қайтқаннан кейін де докторантурамен не істей аласың? Докторантурамен көбіне бізде университеттерде жұмыс жасайсың, шетелдік,
Мгм.
әсіресе шетелдік дигримен. Сондықтан ойладым, так, біздің университеттер, ең мықты деген университеттер сол Астанадағы назарбаев университеті, әсіресе инженерия жағы.
Мгм.
Сол жағымен енді мен Астана IT-ді мүмкіндік болды, сол жақтан оффер болды.
Мгм.
Заодно неде назарбаев университетте жаңа бір проект ұтып алған тұғым, AI-ға байланысты. Осы
Мгм.
3D принтерді қолданып, AI қолданып, бір не жасау болды, бір методология. Сосын Астанада IT-да жұмыс жасап жүрген кезде байқай бастадым, көбіне бізде студент көп болды, өте көп болды. Жұмыс, сабақ беру несі уақыты көп болды да, workload өте көп болды, teaching
Мгм.
workload өте көп болды. Мен R&D-ға көбірек көңіл бөлгім келді да, жаңағы проекттермен,
Мгм.
сол үшін назарбаев университетке жиі барып келіп жүрдім. Сол кездері кішкене ойлана бастадым, менің уақытым бола алмай бастады деп ше. Көрген кезде PhD кезінде андай heavily R&D жасап жүрдік та, и соның базасы, соның несінде мақалалар жазып жүрдік. Андай applied нәрселер жасап жүрдік та. Негізі магистратураның кезінде көбіне андай atomic levelда, microscopic levelда жасаған едім да, нені, материал сайенста. Одан кейін мен ол көзбен көрмегеннен кейін, қолданбағаннан кейін мен оны қалай жасаймын деп бір жыл gap year алған едім. Содан кейін PhD-де сол mechanical таңдадым, мындай біз қолмен көріп ұстай алатын, бірден неде индустрияда қолдана алатын заттар жасайыншы деп. И сол мақсат жасалмай қалғаннан кейін, Астана IT-ді университетте, мен жаман болды демеймін, жақсы болды. Бірақ өзімнің алға қойған мақсаттарымның бірі сол болған еді да, R&D-де көбірек көңіл бөлу. Сол үшін жан жаққа тапсырып бастадым. Кореяда да енді мүмкіндіктер болды. Маған бұны Америкадағы досым жіберді негізі. Оның профессоры, Кореяда профессор жіберген екен, осындай бір позиция болып жатыр, ашылып жатыр екен. Мен ұмытып кеткенмін, Кореяға баруға қайтып туралы ойда болған жоқ. Сонымен енді жарайды енді, бірақ бүкіл кәрісше болды. Қазір де инжиниринг нәрселердің бәрі кәрісше. Мен бүкіл дегелей магистратура, бакалавр, PhD бәрін ағылшын оқып қалдым да, вообще кәрісше инжиниринг нелерді білмедім. Сөйтіп былай қолданбалы кәдімгі күнделікті күнде қолданып жүрген кәрісшеміз бар енді. Соны кішкене отырып терминдарды андай интервьюға дайындалған кезде де кішкене чалленджинг болды. Сол индустриядан академияға, бірінші сұрағыңызға, индустриядан академиядан индустрияға кету мәселесі солай болды. Teaching workload көп болды, R&D-ға көп көңіл бөле алмадым. Содан позициялар іздей бастадым, Samsung Electronics, жан жақты. Немесе академик профессор позициондар, которые более teaching workload азырақ, бірақ R&D-ға көбірек бөлетін. И соның бірі осы opportunity болғаннан кейін тапсырдым, ұмытып кеттім. Бұлар документ скрининнен өткізді. Тіл не болды, сертификат керек болды. Оны барып Кореяға барып алып келдім. Соған бола как раз шетелдіктерді алып жатыр екен. И оларға да 3D принтинг жақсы білетін бір адам керек болған екен, как раз сол неге сол департаментқа. Потом біз бүкіл интервьюлардың бәрі кәрісше болды, есімде ағылшынша араластырдым кішкене. Бірақ енді реквайрменттен асып тұрды да. Сосын оффер келді, кәдімгідей ойландық, қайттан Кореяға барамыз ба деп. Суонда жұмыс, бірақ мен өзім отбасыммен Сеулда тұрамын. Сеулда отбасымызбен тұрамыз, сол жаққа барып келіп тұрамын. Енді бұл екінші сұрақ. Үшінші сұраққа байланысты қайтып ол ойда бар ма не бар деген сияқты. Егер де басында кәдімгідей кішкене өкінгендей болдым ба деп ойладым. Өйткені бүкіл кәрісше болды ғой. Көңілім түсінбей медиктарға барамын. Ағылшынша нелер тіпті қытайша да қолданамыз кейде. Өйткені қытайлықтармен де не болады ғой. Вендорлар, компаниялар Қытайдан бар да көбіне. Өйткені Москвада үшін шығаратын болған Қытайда арзанырақ. Бірақ қазір біраз үйреніп кеттім, енді жарты жылдан асты ғой. Отырып бүкіл терминдарды алфавитті үйренген сияқты отырып ағылшынша нелерінде кәрісшеден ағылшыншаға аударып отырып үйреніп алдым ғой. өзім де қазір презентация жасап сөйтемін уже, короче, бір
м,
енді қайтадан ойда бар ма дегендей, кейде болады енді R&D индустрия несі демант өте мындай
м,
стрикті, өте қатал несі
м,
требованиялар. Өйткені бағасын төмен түсіру керек, саған
м,
қарап қалады да, сен қате жасасаң бүкіл нәрсе бәрі кетеді дегендей үлкен
м,
маңызды проекттер ғой. Жақында бір жаңа модель шығады. Бәрі айтады, біледі, триполд шығады. Қазіргі полд қой,
иә,
екі рет не қылады бүйтіп. Соның несі, сол проектте қазір.
м,
Ә, сосын Қазақстанға немесе басқа елге профессор позициясы ұсыныстар болып жатса, ойланамыз, ойнап.
м,
Жақсы
жақсы.
мүмкіндік болса. Бірақ өзімнің R&D активитилерімді әлі күнге дейін жалғастырамын. Пейперларды
М,
оқып.
м,
Өйткені
м,
біз R&D жасамасақ, cutting edge не болады, не болып жатыр, соның бәрін бірден индустрияға алып келеміз да.
иә,
Академик пейперларды оқимыз, күнде оқимын. Мен күнде оқимын. Соны
иә,
алып, біз индустрияда қалай қолдана аламыз. Proof of concept
м,
жасаймыз. Содан
м,
кейін ол кәдімгі неге өтеді.
м,
Келесі стадияға өтеді. Ол жаңағы advanced project деп айтады. Соған сәйкес келеді ма. Одан кейін барып үшінші стадия mass production. Сол
м,
proof of concepттен өтіп, екінші стадияға өтіп, одан кейін mass production несі жасала бастайды да.
м,
Яғни simple сияқты, кішігірім сияқты көрінген идеялар
м,
нелерде, публикацияларда негізі
м,
масс продакшнға әсер етеді. Қазір мысалы тыңдап отырған докторанттар немесе жаңағы ресерч сайентисттер болатын болса, яғни
м.
don't underestimate да, яғни өздеріңізді төмен түсірмеңіздер, жазған публикацияларды по-любому әйтеуір бір инженер неғып оқып, одан кейін кәдімгі шын өмірде коммерциализациялауда қолданады.
иә, ол абек дұрыс айтасыз. Ал сізде департаментта бәрінде PhD-сі бар шығар, иә, коллегаларында? И промоушен
Бізде
PhD-мен тезірек болады.
иә, дұрыс айтасыз. Магистратуралары барларды алады, бірақ көп опыты болған адам керек. Бірақ қазіргі кезде бізге көбіне докторантуралары бар адамдар керек деп жатыр да. Егер де сондай таныстар болса, не болса, андай короче несі минимум бізде 6 левел бар. Соның
М,
үшінші левелдан жоғары болса деген сияқты.
м, м,
Бірнеше жігітке офер деп, жаңағы recommendation letter жібердік. Өзі
м,
Кореядан неде жүрген, енді тіл біледі ау деген. Өйткені
м,
неге десеңіз, Кореяның қазір туу несі рейт төмендеп кетті да, бірс рейт өте қатты төмендеп кетті, даже 0,6 ма сондай. Ол дегеніңіз екі отбасыға бір бала деген сөз ғой. Екі
м,
отбасыға бір бала деген сөз, ол Кореяның өзінің индастри requirement экономик несіне әсер етеді да.
иә,
Сондықтан бұлар қай жақтан алады да, шетелден иммигранттарды алады, қандай адамдарды, андай академиктер, PhD-лар барлар, сондай адамдарды тартып алады өздеріне.
м,
И солай экономикасын стабильно ұстауға тырысады.
м. Иә, түсінікті. Иә, рас, бізде де сондай, Германияда өте төмен. Мына жақта рахмет, Уламбек, менің сұрағыма.
Мгм.
Екінші Марленнің сұрағы бар. Марлен, вы
Мгм.
можете включить камеру, включить микрофон и спросить ваш вопрос, если вам удобно. Как раз Астана IT университетінде оқиды екен, үшінші курс.
Әлем, бай. Так, менің студентім болған жоқ қойған, есімде жоқ. Мен
Ка-
82-ден аса студентім болған.
Пожалуйста,
Так,
Марлен.
точно.
Здравствуйте, Уlanbek.
Ага, салам.
Меня зовут Маклем. Я, получается,
Мгм.
являюсь студентом третьего курса по программе Software Engineering. То есть, да, я вас не видел, но знал через знакомых, кому вы преподавали, то, что
Мгм.
вы есть и какой у вас бэкграунд. Вот, и в целом у вас очень классный бэкграунд, как я и сказал, то, что UNIST, QIST, и сам
Мгм.
собираюсь поступать на магистратуру и выбираю одним из вариантов как Корею, а именно
Мгм.
КС. И хотел бы спросить
Мгм.
о вашем бэкграунде, то есть что
Мгм.
требуется, что ценится условно в КС при поступлении на магистратуру.
На магистратуру в КАИСТ ценится очень большой фокус на э, research papers. И если у вас есть некоторые conference papers, например, да, у нас же есть IEEE, э,
Да-да-да.
да, Astana IT университета для студентов, которые же есть. А вот если у вас experience там, написание публикации, особенно это ценится, если вы пытаетесь поступить в КАИСТ. И еще один момент, вы же хотите в software инженерии, да, на магистратуру. Но не только КАИСТ, я бы тоже порекомендовал некоторые университеты, например, если посмотрите сайт был studyinkorea.go.kr. Там есть систематичные веб-сайт, особенно для студентов. Степ-бай-степ там написано, как податься, на какие, вот, в каком городе, на какие вот majors есть. studyinkorea.go.kr. Если вы там посмотрите, и scholarship JKS, да, вы имели в виду,
Да.
это, блин, очень competitive GKS. Я бы сфокусировался на университетский грант, нежели GKS, честно сказать, потому что, блин, квота в Казахстане, по-моему, для Казахстана меньше, чем 23, что ли. Не знаю, точно не знаю. Ну, конечно, подайтесь, если есть возможность, но я бы советовал написать для профессорам, что я интересуюсь, анау-мынау деген сияқты. И, кстати, и у меня есть презентация на этот момент. Вот насчет этого как раз для студентов я подготовил. Где-то, когда я работал в Astana IT University, у меня была там возможность сделать презентацию для студентов, especially вот насчет Кореи. Вот, если вы оставите свой email, я вам, постараюсь отправить файл.
Хорошо, спасибо большое.
Мгм.
То есть вы напрямую в сам университет подавались, да?
Да. У меня не было не по GKS, не по Балашаху, я просто подался сам, там IELTS, там, ну, и потом написал на магистратуру, по-моему, я лично поехал в КАИСТ, там встретился с профессором, и потом решился, да, учиться или нет в КАИСТе.
Получается, и на докторантуру вы тоже напрямую поступили, да?
Да,
Всё
точно.
хорошо. Так, условно, КАИСТ, как я знаю, есть программа на английском, и, то есть, не обязательно знать корейский, то есть, условно, топик, не обязательно, чтобы он был там высокий.
Не, в
То есть,
КАИСТ, в UNIST, по-моему, нет. Software инженерия не обязательно на корейский, нет.
хорошо, спасибо большое.
Рахмет, Марлен.
Мгм.
Dostar, any other questions? So we have, let's say, 5 minutes more for one question.
Мгм. Мгм.
Жақсы. Онда сұрақтар болмаса, Ulanbek, сіздерге рахмет айтамыз. Әсіресе Дана ханым, Данияр ханыммен бірге жасап жатқан QIST KZ проекті өткенде таныстық. Өте үлкен жұмыс, өте қысқа уақытында жасап жатырсыздар. Сәттілік сіздерге. Сізден танысқанымызға қуаныштымыз. Рахмет бүгін уақытыңызды бөліп, шын мәнінде осы қазақстандықтар бойынша видеоны да сақтап қоямыз. Керек жерлер болса кесіп тастаймыз. Басқалар да көріп,
Мгм.
мүмкін сұрақтары бар болып жатса, мүмкіншілікті бағана жұмыс жайында болса, өте талантты PhD бітірген студенттер бар болса, осы әлем бойынша соларға бір қолдау көрсетіп, осындай мақсатпен жасап жатқан
Мгм.
шара. Рахмет үлкен, Уламбек, сізге уақытыңызға өте
Всё.
пайдалы болды. Иә, и рахмет
Всё,
басқаларға да
жақсы.
қосылғандарыңызға. Жақсы
Мгм.
күндер, сау болыңыздар.
Жақсы. Сау болыңыз, рахмет.